7:55 in the evening, one pressure line on the Deepwater horizon read 0. Another, connected to the same well, still held 1,400 pounds per square inch. A successful test required pressure to fall to 0 and stay there, yet this impossible combination was accepted as a pass. Less than 2 hours later, the rig exploded. 11 workers died, 17 were seriously injured, and oil would flow into the Gulf for 87 days. The test had not failed to warn them. The system had failed to believe it. The test was called a negative pressure test. Heavy drilling mud normally pressed down inside the well, helping hold reservoir fluids underground. To test the cement at the bottom, crews temporarily reduced that pressure, creating conditions closer to what the well would face after the mud was removed. They then bled pressure from the system. If the cement barrier was sound, the pressure should remain at 0 and no fluid should flow. But there was no written procedure that defined exactly which readings counted as a pass, or what to do when the instruments disagreed. The first attempt would not even bleed below 266 psi. On the next attempt, drill pipe pressure reached 0, then climbed back to 1,262. It was bled down again and returned to 773. A third time it reached 0, then rose to 1,400. Every rebound meant pressure was being supplied from somewhere inside the well. The 1,400 psi reading was blamed on a supposed bladder effect in the pipe. But that explanation was never verified. The warning did not disappear, it was renamed. A second test watched the kill line instead. That line showed 0 pressure and no visible flow, while the drill pipe beside it remained at 1,400 psi. The result was declared successful. At 8 o'clock, the crew began replacing heavy drilling mud in the riser with lighter seawater. That lowered the force holding the reservoir back. By about 8:51, the well was underbalanced. Because the cement barrier had failed, oil and gas could now move upward. The false pass had removed the very pressure that had been masking the failure. The incoming hydrocarbons produced signs on the rig, but they were recognized late. At about 9:31, unusual pressure drew attention. Around 9:43, the annular preventer was closed, yet flow continued. The diverter sent the mixture toward the mud-gas separator. Equipment never intended to handle a release of this scale. It was overwhelmed. Gas spread across the rig and found ignition sources. At approximately 9:49, the first explosions tore through the Deepwater horizon. The sequence from a misread test to catastrophe had taken less than 2 hours. Far below the fire, the last mechanical defense was the blowout-preventer, 57 feet tall and roughly 400 tons. Its blind shear ram was designed to cut the drill pipe and seal the well, but pressure had buckled the pipe off-center. The ram likely activated and cut only partway through. The cement failed. The pressure test failed to stop the operation. The kick was detected too late, and the blowout-preventer could not seal the well. Oil flowed for 87 days, about 134 million gallons. Deepwater horizon was not a single broken part. It was a warning accepted, followed by every remaining defense failing in sequence.